So thanks, Mike, and thanks to the organizers who we should all give a hand to now for a fantastically nice conference full of all sorts of interesting conversations. So. Great. Okay. So what I'm going to talk about is a part of a sort of project or a book I've been writing, which has lots of loose ends, and I hope to be some of which I'm aware of and some of which I'm not aware of. And I hope to find out about some that I'm not aware of yet from our conversation at the end of the talk. So what I'm interested in doing is answering this question of that Stephen Hawking colorfully poses. So going back a little bit to the origin of the concept and the notion of laws, is that the usual story is that the notion of law of nature really wasn't a prominent notion within science until the 17th century, particularly made prominent by Descartes and Galileo, Malebranche, Boyle, and some contemporaries. They call these principles laws of nature to emphasize their governing role. So their idea was that laws are mathematical principles that described how God governed the motions of material bodies. Whatever one thinks of the theological origin of this notion, it was enormously fruitful and it led to a successful program that involved Newtonian development of the Newtonian mechanics and electromagnetic theory and so on. And some physicists even dream of what's been called a final theory. Steven Weinberg is one of the dreamers, as other physicists are. A theory that unifies relativity and quantum theory and will cover all elementary particles and fields. It would be a relatively simple system that specifies the fundamental laws that govern the motions of all bodies and is the source of the lawful behavior of all physical phenomena. The idea of a theory of everything, well, it's even thought that we're not so far, or current physics is not so far from finding an account of at least a theory that governs all of macroscopic phenomena under under the usual conditions we encounter. And here, I'm not going to explain any of this, but this is Sean Carroll's a version of it in one of his books. Anyway, so while it's the job of physics to say what laws and probabilities there are, it's the job of philosophy to say what laws and probabilities are. And I'm going to say a bit about being a philosopher about the second of these. So first I thought, although this is going to be familiar to pretty much everybody here, just sort of give a little bit of lay of the land discussion. The contemporary views about the metaphysics of laws basically divide up into three accounts. Best system Humean accounts, which construe laws as propositions that fit into a scientific systematization of metaphysically unconnected fundamental events. And so-called powers, anti-Humean accounts. There are two kinds of anti-Humean accounts: powers accounts, which construe laws as generalizations made true by the activity of powers. And there are primitivist anti-Humean accounts that construe laws as metaphysically fundamental items over and above the phenomena that in some way constrain or govern the evolution of events. That view is closest to the way the notion of law was introduced by during the 17th century. So what I'm going to do is to describe another account. It's not exactly a new guy on the block because it's close to Lewis's best systems account. But where Lewis describes his account as a package deal, since it packages together laws and probabilities, the package deal account, which I call a PDA, rejects a supposition of Lewis's account. And the supposition is that the Humean mosaic consists in the instantiation of what he calls perfectly natural properties, and instead takes a pragmatic and naturalistic turn in order to produce a package which puts together for the fundamental properties with fundamental laws and probabilistic laws, and is the source, I think, of all laws. In fact, all norma is the ultimate source of all nomologicality. And we'll get to talk about that a little bit. I think of Tim Maudlin as my main foe, mainly because he's a friend and lives down the block. And maybe it's a good idea to have his view in mind when thinking about why one might be interested in Humean accounts. So here's a description of what God would need to do to create the universe. According to Lewis, what God needs to do is to create a space-time or a manifold of points in which the fundamental properties and magnitudes, what he calls perfectly natural properties, are instantiated, and the totality is, as he calls, the Humean mosaic. And his claim is that all else, including laws, objective probabilities, causation, counterfactuals, mountains, haircuts, everything else, supervenes on the Humean mosaic. And on Humean view, laws don't govern and they don't constrain. So it's revisionary from the way the notion of laws was introduced in the 17th century. And further, there are no necessary connections, that's why it's called Humean, among properties instantiated at distinct points. Maudlin's view, on the other hand, is that what God does is create also a manifold with geometrical structure that's equipped with a temporal dimension and a fundamental direction of time. And there's an initial distribution of fundamental properties and relations. And then there are primitive, metaphysically primitive, let's say fundamental dynamical laws that govern by taking the initial state and evolving it to the states at subsequent times. And for Maudlin, this important point, the fundamental properties might not be, as Lewis thinks, they might not be categorical, they might not be intrinsic. So a question one might ask is, why should one be anti-Humean? So Maudlin gives his reasons. He says that it's because he wants to be conservative. The anti-Humean view endorses certain intuitions that we have. I think I saw John Carroll here. So John Carroll gives the best discussion of what these anti-Humean intuitions are and uses them as an objection to Humean view. But we definitely have anti-Humean views when we start thinking about laws. These intuitions, though, I think echo the theological origin of the concept of the notion of laws of nature. And so Maudlin says, as a quote, why not just accept that the concepts of laws and chances are basic, and that law, and what he means by that is metaphysically basic, that the items are metaphysically basic, and that laws and chances are not reducible to anything else. Okay, so that's one stand one might take. The Humean, of course, is taking the opposite stand, that what laws and chances are is reducible to the Humean mosaic. So why be Humean? Well, Tim has a paper with this title, and he attributes to being Humean Hume's views, Hume's reasons, which were because we don't have an impression of necessary connections between events. But I don't think this is a good reason for not be, for a good reason to be Humean. The reasons that I'm Humean is I just absolutely don't understand what these governing laws are without the theological story that goes along with it. With this, I'm with Nancy Cartwright, although I think I disagree with her about much everything else. I don't understand where they exist, if that even makes sense, and most importantly, how they're supposed to do their work, how they govern. So, and I think that governing intuitions regarding laws are holdovers from the theological origin of the concept. Laws don't explain by governing, but rather, I think, more by unifying or by supporting causation on a Humean account of causation. Humean accounts of laws and chances connect them with scientific practice and explain why knowing them is of value. So that's why I'm a Humean. So here's Lewis's account of laws and objective probabilities. I think because I'll get hoarse, so I've had a bit of a cold, I won't read it, but all of you are familiar with Lewis's account of laws. So here it is. What is important to keep in mind, because I want to say a little bit about probability as this talk goes along too, is that that probabilities are introduced as a means of enabling the laws to express a great deal of information without becoming complicated. And it's unlike the anti-Humean view, which says that what makes something a law is its connection with necessary connections or with governing. It's rather, for the Humean view, it's in virtue of an equation or a generalization's or proposition's role in an optimal scientific system that it expresses a law. Okay, I think I'm gonna skip a little bit about probability. So just mention something about space and time, which I think is an important advantage of Lewis's account that he doesn't take fully advantage of. But one could just start not with a space-time structure as Lewis does, but with just a manifold of points with topological structure, and then understand the geometry as physical geometry as itself emerging from the best system as laws of space and time. And the best system could then determine which dimension is temporal in terms of which other laws, if there are any other laws, play the role of dynamical laws, and the direction of time by the lawful patterns among events in that dimension. So that's what's done in statistical mechanical accounts of time's arrows. So Lewis requires perfectly natural properties in his account. And this has come up before, but let me just mention it to keep it in mind. Lewis says that a preferred language in which to formulate candidate best systems is required in order to evaluate simplicity and informativeness. Otherwise, and this is his example, though I didn't use his symbols, I guess, a proposition, everything is F, would win as the best system, where F is a predicate true of an individual just in case it exists in the actual world. Because this proposition statement, everything is F, is very simple, and it would be maximally informative on Lewis's account of information, where Lewis measures information in terms of the number of possibilities excluded, numbers of possible worlds excluded. So he takes that as a reason to say we should restrict the languages in which candidate systems for which is the best system can be expressed to a language whose atomic predicates and functions and other terms are restricted to those which refer to perfectly natural properties and other ontology. And FX clearly doesn't, given what he says about what perfectly natural properties are. So that gets rid of this objection. From my point of view, and this struck me from when I first read it, this looked like using a hydrogen bomb to kill a flea, that one really didn't need to go this far. One could have been a little bit more delicate about how one wanted to talk about information in the account. But what are perfectly natural properties for Lewis? And my way of understanding Lewis here is going to be important. And I'll be interested in whether other people understand Lewis differently from the way I do. So for Lewis, the existence of perfectly natural properties is a metaphysical presupposition of physics. Perfectly natural properties play a crucial role not only in his characterization of laws, but he uses them elsewhere in metaphysics, in his accounts of resemblance, intrinsic duplicates, in his account of possible worlds, and his recombination principle, and his account of reference. And a question that might occur to one is, why think that one kind of property can do all these jobs? So there is a kind of property that can do all of these jobs. So, and this is important to the rest of my discussion, Euthyphro has come up a few times during the talk. So here's me bringing up Plato's Euthyphro. Here's the Euthyphro question about laws and properties. Are properties natural because they figure in laws, or are generalizations laws because natural properties figure in them? So Lewis's view is the latter, I think. He takes the notion of natural property as being fundamental and uses it as in his characterization of what laws are. I'm going to take the opposite route. Here's a little quote from Lewis that I think makes pretty clear that Lewis has the view that I'm taking. Of course, Lewis does think that it's the aim of physics and fundamental physics to discover what the perfectly natural properties are. But he also thinks that it might not succeed in that, though he thinks that there's a good argument that can be made that the best examples we have of perfectly natural properties are those provided by physics. And he gives us examples, mass and charge and spin. I'm not sure that this is what a physicist would give, but anyway, that's Lewis's. Okay, so Lewis's best systems account has a lot of virtues, many of which have come up in previous talks. One is that it connects laws and systems with the epistemological and the other criteria that physicists use in evaluating theories, because we do think that simplicity and informativeness are physicists do think simplicity and informativeness are important features. And also, there's no appeal made to governing or theology, or to a primitive direction of time. And I guess the fact that I put those together probably indicates that I think of them as belonging together. Also, on his account, that laws explain by systematizing and unifying patterns in the mosaic and by supporting counterfactuals and causation. So I think that this fits right in with Lewis's account of laws. And I also think that it's the fact that it can treat geometrical structure as themselves lawful, and the distinction between time and spatial dimensions and time's arrows as a consequence of laws is a nice virtue of the account. And also, for me, what's really important is that by connecting probabilities with laws as probabilities being introduced in order to make for laws that are both highly informative and simple, is that it provides a way of making sense of the notion of probability. Immediately comes to my mind a quote from Russell. I think Russell said someplace, probability is the most useful concept to the sciences, especially since nobody knows what it is. But I think Lewis's account does provide the ingredients to begin a good account of what objective probabilities are. And also, although Lewis didn't think this, an account of the objective probabilities that occur in statistical mechanics and in Bohmian mechanics, where the fundamental dynamical laws might be deterministic or are deterministic. But there are lots of problems that people have brought up with Lewis's best systems account. I'm going to mention a few, and then I'm going to talk really just about a couple of them. One, which there's a lot of literature has been produced on about this, is the argument that, look, Humean laws are a poor facsimile of the real thing, because they really can't provide explanations. Okay, and the reason they can't is that because on Lewis's account, what the laws are supervenes on the Humean mosaic, they couldn't explain anything in the Humean mosaic without circularity. And this is a charge that was made by Tim Maudlin, Mark Lang very nicely and clearly, by Nina Emery in another nice paper about this. And I think it's right if what they think that explanation by laws involves something like governing or production or constraining. The Humean laws can't do that, okay? But I do think that they can explain in the way that's I call scientific explanation, which involves unifying and by backing causal explanations. Now, there's a lot that needs to be discussed in order to develop that idea, but I'm not going to do that today. There's also this interesting objection related to that, and that is that someone might think about Humean mosaics in general, all the possible Humean mosaics that could be, and if you think about them like that, it'll occur to you that most of them won't be systematizable. They won't have Humean laws at all. And then it might strike one that it's sort of a fluke or an accident that it turns out that the actual mosaic, the actual world, is systematizable. This is an objection that's been made by Galen Strawson, I think John Foster, and Dustin Lazarvici develops it in the best way, I think. But now, just repeating something that Toby Friend said in his talk, the trouble with this objection is that the whole idea of what a fluke is or what luck is only makes sense relative to what the laws and the chances are. So I think that this objection, while it grabs you intuitively at first, I think it's a bad objection for this reason. It depends on really an account of what laws are. An objection which I do think is important is that the criteria for evaluating candidates for best systems that Lewis gives are vague and they're underdeveloped. Now, a lot of the development of these has been made by those people who have taken the pragmatic turn. I mostly agree with what Toby Friend was saying in his talk, that in fact, informativeness and simplicity are sort of at the head of what we think of, what physicists think of as what's important in systems of laws, in evaluating candidate systems of laws or candidate theories. But I think information has to be understood properly. And the way I like to understand these criteria is that they actually come out of the history of physics. So the way physicists understand them has changed over time and probably will change in the future as physics develops. Okay, so here's the other problem. The other problems have to do with Lewis's basing his account on perfectly natural properties. So perfectly natural properties for him have to be categorical. That means that they have no necessary connections or lawful or causal connections with their instantiations, have no connections with instantiations of properties in distinct spatial locations. And a worry that people have about categorical properties is that they seem to entail quiddities, that the categorical properties aren't what they are because of what they do, but from what they are, that's it. And Lewis embraced this and announced it as a thesis that he called Ramseyan humility. I'm not sure I want to go along with that. We'll come back to that a little bit later on. But also we have intuition that nomological connections are, at least to a certain degree, essential or at least important in individuating fundamental properties. That's one reason somebody might get worried about Lewis is building this account on categorical properties. But the more important objection is one that has been developed by Tim Maudlin and by Kerry McKenzie and a few other people And that is that there are theories in fundamental physics which make use of notions which seem like they don't fit in to Lewis's account of perfectly natural properties, because well, the example that's been the one that's been discussed the most are the quantum state, because the quantum state involves isn't instantiated at points. It involves something like a relation, or maybe it involves there being a spatial temporal arena, which is a very high dimensional, or maybe it involves some kind of ontology over and above anything in the Humean mosaic. But there are other properties that occur, or features, quantities, and magnitudes that occur in the standard model and quantum field theory, which aren't don't fit into Lewis's account of perfectly natural properties because they're not categorical. Okay, but my main worry, and the one I'm going to mostly talk about, is that Lewis's account depends on this metaphysical posit. And I wanted to take seriously the idea that we should do as much a philosophy of physics as possible without appealing to metaphysical presuppositions to physics, as opposed to explaining metaphysical notions in terms of physics. That's what I'm going to try to do. Okay, so these are the reasons now for why I try to do without perfectly natural properties. I mentioned a few of them already. There are the conflicts with physics I just mentioned. There's this business about quidditism. There's also something called the mismatch problem, which we'll talk about later, was brought up originally by von Frosten and discussed very insightfully by Heather Demarest. And another problem, which hasn't been that much discussed in this literature, brought up by Shamik Dasgupta. And basically, it's because I want to give an account of laws that presupposes as little metaphysics as possible. So I think I'm going to skip the discussion about the conflicts with physics, because that gets a little bit technical. And instead just say a few things about this business about quidditism and its opposite, because it puzzles me a lot what to think about it. Maybe somebody here will have something interesting to say or point me in an interesting direction about it. Okay, so Lewis says that categorical properties are what he calls quiddities. So quiddities are for properties what hexities are for individuals. That is something we know not what that makes it the property that it is. This is important to Lewis because he wants to individuate properties in a way that in which they don't have necessary connections to one another. That is, they're instantiations in distinct locations. The space-time locations don't have necessary connections to each other. That's very important to his recombination principle, to his account of possible worlds. But having properties like this allows for it to be the case that categorical properties, it's possible for categorical properties to swap roles in the laws without making any difference to the nomological structure of a world. So for example, assuming that negative charge and positive charge are perfectly natural properties, there would be two possible worlds which have the same nomological structures, but in which every place positive charge is instantiated, negative charge is instantiated in the other world, the corresponding places. Some people have thought that this is a worry because it leads to a kind of skepticism. That's what Lewis seemed to think, but he embraced it. I'm not sure about that, I'm worried about skepticism. But what I am worried about is it seems to make for a difference in the metaphysics, which makes no scientific difference. So I don't like quiddities much. I'd like to do without Lewis's quiddities. The alternative to quiddities is to say that perfectly natural properties are something like powers. They're dispositional. And there are counts of laws, as I mentioned earlier, which are built on the idea that the basic fundamental properties have necessary connections with one another, and that laws are a consequence of this. I don't like this view either, partly because it dissociates itself from the best system account, although Heather Demarest tries to reconnect the two. And I don't like the anti-Humeanism in it, that by making use of the notion of necessary connections as being something fundamental. But also there's a worry that's been brought up about whether it's even possible or whether it makes sense for all the fundamental properties to be powers. Bertrand Russell brought this up. I can't remember right now exactly where this occurs. Maybe somebody here will remember, but he objected to the view with a very interesting phrase that's puzzled me ever since I encountered it. He said, if the world was like that, it would be one in which all the fundamental properties are each other's washing. He meant that as an objection. If anybody here knows what he had in mind, I'd be interested to hear what you say about it. Anyway, here's what the mismatch problem is. This is, like I said, was brought up by von Frosten. It's the problem that even if physicists came up with a theory that satisfied all of Steven Weinberg's wildest dreams of a theory of everything, it might be that on Lewis's account of laws, Weinberg's theory of everything wouldn't get the laws right. And that's because its fundamental predicates might not pick out the fundamental properties. And in fact, you can cook up examples in which not only would such a theory get the fundamental properties wrong, because its fundamental properties wouldn't be the perfectly natural ones, but it actually get the laws themselves wrong. So you can imagine a theory which imagine that the actual world has natural properties such that if one were to really come up with the best systemization of the perfectly natural properties, it would be more complicated theory than the theory that's constructed by Weinberg's theory of everything, which gets simplicity it gets to be simpler by having by referring to properties which aren't the metaphysically fundamentally perfectly natural properties. Okay, so some of this is that Lewis's best system account is subject to what you might think of as an epistemological disconnect that the account also accuses anti-Humean accounts of. I just, for my own sake, mentioned to you that I actually had a conversation with Lewis about this. Literally, it was 2 weeks before he died, and we were supposed to talk about it later, but didn't get any opportunity to. Lewis made the interesting suggestion that maybe his use of perfectly natural properties in the theory of reference would prevent the this mismatch problem from arising. And I've since then been trying to figure out how that might work, and I haven't been able to figure out what he might have had in mind about that. Okay, so I think that's a problem. Incidentally, it's not just an epistemological skeptical problem. I mean, somebody might say, well, of course, physicists might not come up with the right account of what the laws are at any time in the development of physics. But the idea here is that a theory which satisfies all of the criteria that physicists place on the nature of physics and is true would get the laws wrong. And I think that is a problem. It's sort of the metaphysician telling the physicist what is his job. Okay, here's what this problem is. Incidentally, Mike, if you're listening, can you wave your hand when I have about 10 more minutes? Okay, good, thanks. Um,
It's depending on how much you want to leave for the question and answer period, it's about now for 10 more minutes.
it's about 10 minutes now?
Yeah, you
Good,
can
then
go a
it'll take
little longer, but if you
no,
want.
I think I can finish in 10 minutes, good. Okay, so here's what that scooped this problem. I mention it mainly because I think his paper is a great paper and you should read his paper. It was in Phil Review a few years ago. And he brings up a worry about perfectly natural properties of this sort. He says, Lewis says that the laws should involve perfectly natural properties. But what's so great about laws involving perfectly natural properties? What's so great about them? I mean, this feature of metaphysics. There are other properties that aren't perfectly natural. He calls them the perfectly natural star, the perfectly natural star-star properties. Remember, for Lewis, properties are abundant. There are lots of them. The perfectly natural ones is a select set. So what's so great? So to scoop this question is, what's so great about the perfectly natural properties? I really like this kind of question that the Scoopta asks, because whenever one is given an analysis, an identification of some notion, which is useful and has value, one wants to know whether the identification that one has made of it itself has value. In fact, I think this is what was going on in the paper that Mike et al. Was giving yesterday. They were asking the question of what makes laws on an anti-Humean or a Humean account, what makes them valuable? And they had an answer to that question. Similarly, one might ask this question about any account of objective probability. Why should that be a guide to our degrees of belief? And I think these are good questions. So why should laws, as characterized in terms of perfectly natural properties, um, have value for us? And I don't think it's an adequate answer would be to say, well, they're the ones that guide physical theorizing because they're the ones that are perfectly natural. After all, the word natural, carries a lot of weight. They're natural, after all. But this isn't a good answer. Lewis himself should say it's not a good answer because, to borrow a quip of his, it would be like saying that Armstrong must have strong biceps because he's called Armstrong. Okay, so we'd like an answer from an account of what laws are, for why it's valuable for us to fund people. We do the funding, but the other people, the physicists, spend their time trying to find them. The other scientists spend time trying to find them. What's so valuable about them? Whatever we identify laws with should provide an answer to that question, I think. And Lewis's account, if it doesn't provide an answer, and one wonders whether it can provide an answer, given the fact that perfectly natural properties are introduced as a metaphysical presupposition to physics. Okay, so I'm going to tell you now about my account, which is the package deal account, which provides answers to these. So its main idea is that it dispenses with metaphysically primitive, perfectly natural properties and the Humean mosaic as Lewis conceives of it, and replaces it with a package. And what the package does is it posits a manifold or arena, a language whose basic non-logical mathematical terms refer to what I'll call fundamental properties, but there's no assumption of anything metaphysical that these refer to Lewis's metaphysically perfectly natural properties, and a system or theory that systematizes all the truths expressible in L. Okay, now what it is to systematize all the truths in L, I'm not going to have time to say that much about. Part of it is that it'll systematize the fundamental truths in L along the lines that Lewis describes. It'll be highly informative and simple about them. But I think it's going to need to do more than that. It's going to need to systematize also truths that are not expressible in the language of fundamental physics, but rather truths that are related to truths in the fundamental language of physics by being grounded in them or entailed by them or necessitated by them or something like that. So in particular, the idea behind this is that, look, how did physics start in the first place with Descartes and Galileo and Newton and all? They were interested in the motions of material objects and planets, pendula, projectiles, and so on. And what we want from physics ultimately is an account, a systematization of the motions of all material objects, well, physical objects. Much more than that, we're going to want more than that too, because in the course of giving an account of that, physics is going to posit other kinds of features of the world, and it'll need to give an account of their motions or their changes as well. Okay, here's an assumption I'm going to make that may come up in the discussion. I'm going to assume that the world, by which I mean the universe, the possible world, the way things are, has sufficient structure to provide truth conditions for all the sentences in this language. There's a little star there because I was going to put in a footnote and I forgot to do it, so I'm not going to say anything more about that. Okay, so here's the way the package deal account works. Consider all the totality. Now, when I'm saying consider, I don't mean for you to stop now and consider all of them. Nobody's ever going to do that. It's rather that in principle, there exists in some way all the possible languages which specify arenas and theories. And call these the candidates. Okay. These are all the candidates for what the basic system of the world is going to be. Okay. In fact, we can think of them as candidates for theories of everything, because theories of everything will have all of these ingredients in them. Okay. So the idea is to select from all of these candidates the one or the few that have these features. They're true, and they best systematize, given the account of systematization that we want to give, all the truths that occur throughout the arena by combining various scientific virtues, simplicity and informativeness, of course, that are important, and all of the others. And an important one for me, and here's the word I like to use, the describability of the non-fundamental in terms of the fundamental. That is to give an account of the motions of macroscopic objects and events and the special science laws and counterfactuals and causation and so on. Obviously a big project, but I see Lewis as beginning to undertake a lot of that project in most of his work. I don't think anybody has really completed that project, of course, or even that there are lots of places in there where things don't work out right. In Lewis's account, where things don't work out, and even places where other people, including myself, have tried to fix Lewis up a bit, things don't work out quite right. But anyway, the idea is that the law-giving system is the winner of this competition. It's the scientific conception of the theory of everything. So there are a bunch of criteria that I've thought of, some of which have come up in previous discussions. But as Toby Friend pointed out, really at the top of these criteria is that where we wanted these systems to be comprehensive and to be simple and as informativeness understood in the right way as possible. There's a nice discussion of this of these criteria in a number of papers by people who are here, but also by a paper by Craig Callender, somebody might look at. But these need much more development and discussion. Okay, so here's the basic idea now. I think I've got it across and I can come close to stopping. So here's the package. It's a package of fundamental laws and probabilities and space-time and fundamental properties all together. Okay, and it's the package that's given by the best system, the theory of everything of our world. Of course, an issue might arise immediately in your mind, and that is, what if there are ties? What to say then? Let's leave that for the question period, okay? So here are some virtues of this account. Mainly for me, that it preserves what I think is the really great idea of the best system account, and that is that it specifies what laws are and what objective probabilities are in virtue of their role in systematization and systematizing. Okay, but it gets rid of the reliance on its metaphysical positive, perfectly natural properties. I got worried during Vera's talk that my view she might think of as fictional, but we had a little exchange and she told me that it wasn't fictional by her account of fiction. And maybe that'll come up in the discussion too. Okay, and it doesn't face the mismatch problem. And without going into it in much detail, I think you can see what kind of answer I will give to Dasgupta's missing value problem. The value comes from the fact that a community of physicists and us who endorse what they're doing value finding a system of this sort. That's where the value comes from and why the system has value. Okay, so just by way of conclusion, the package deal account is an account of laws which is similar to Lewis's, similar spelled correctly, we hope, to Lewis's best system account, but in that laws don't govern or depend on necessary connections. But unlike the best system account, it doesn't depend on the metaphysics of perfectly natural properties. And so taking this pragmatic turn enables it to overcome some of the objections to the best systems account. So thanks, Sam.